This video describes the preparation, handling, and splicing of optical fibers. Which is routinely found on top of telephone lines. The first step is to remove the cover of the FOSC by rotating it in a counterclockwise direction and pulling it straight off. This particular FOSC is a series of 4 different trays which contain loops of optical fiber, 2 of which we'll be splicing together. One of the most important aspects of this lab is to learn how to handle the fiber in a delicate but direct fashion, which will result in optimal placement that will be best for the fiber's longevity and also for subsequent technicians that will work on the fiber. Once the tray is revealed, we go to the designated tray, which can be lifted up and revealed like so. We'll assume that we're going to be working on the top tray today. The plastic retainer cap is then gently pulled off and put to the side. This particular tray has 2 groupings of fiber. One grouping on the right-hand side of the tray is fibers which have already been spliced together. Their splice protector sleeve has already been inserted, and there are 2 of them here, and the corresponding fibers for those spliced fibers are looped on the right-hand side of the tray, using the tabs on the side of the tray to hold the fibers in place. On the left-hand side of the tray is a grouping of fibers which have yet to be spliced. These are the fibers we're interested in. We'll be removing the fibers on the left-hand side of the tray and cleaning them off in such a way as to not disturb the fibers which have already been spliced. And this is tricky and requires a lot of practice in handling. The first thing we'll do then is gently lift off the fibers on the left-hand side so that we can find the fiber that we're going to splice today. The next step is to take some isopropyl alcohol and a Kim wipe and dampen it with the isopropanol. And very gently, taking the fibers in your hand, run the isopropyl damped Kim wipe down the fibers to clean off any dirt. The other important aspect of this is that the fibers that are going to be used or spliced together today need to be separated from all of their other companions right back to the 2 sleeves where the fiber bundles enter into the tray. This particular fiber bundle is 6 and 8, and there are 2 bundles associated with those. The 2 fibers we'll be splicing together today will be the flesh or pink colored fiber coming from bundle number 8. We have to separate that particular fiber from bundle number 8 without again disturbing the already spliced sleeve. Identify the flesh colored one here, and you'll find, as usual, it's kind of tangled with the other ones. It's very important that we try to gently separate this from the fiber all the way back to the sleeve that entered into the tray. There's number 8 pink or flesh colored. Here's the rest of 8. Put that down here. I'm going to be splicing that to number 6 blue. So I'm very careful here. I should be able to separate. Blue from number 6 appears to be here. And using the tweezers, I very carefully separate it from the rest of the fibers. It takes a lot of patience. I've got the 2 fibers that I want isolated from the rest. I put those off to the side in the front here, and I'll group my unspliced fibers together and put them off to the back of the tray. Keep them out of my way for now. And you see, just in this process, I've managed to disturb the loops of the previously spliced fibers. I'll try and put those back in place. I do this, and there. Now, it's necessary for me to prepare the two ends of these blue and pink fibers to ready them for the fusion splicing. The first thing to do in the process of preparing these fibers for splicing is to make sure you take a protective sleeve that will eventually go over top of the fused fibers and insert it over one of the existing fibers. In this case, I'll put it over the pink fiber. This tube has a metal reinforcing rod in the middle, and it's actually a sleeve within a sleeve. We make sure that we put this in the inner sleeve of the tube. It's actually very easy to forget this step, and unfortunately, if you do forget this step, you'll have to start all over again after the splice is done. The next thing we need to do is we need to remove some of the protective outer jacket from about the end 2 inches or approximately 5 centimeters of the fiber. We do this by wrapping the fiber around my finger to reveal the last little bit of fiber, and taking the miller cutters, we fit the fiber into the V-groove of the miller splicer, and in one motion, with the cutters tilted 45 degrees toward me, I move it away, and in that way remove this protective sleeve from the fiber. This is the last time that I will be cleaning the fiber. I take a piece of Kim wipe, moisten it with isopropanol again, and wipe off any existing scraps of the protective sleeve. Squeaks. Now I take this fiber and I put it into the York automatic cleaver and lay it in the V grooves between the two parts of the York cleaver. I've already made sure that I've got all of the switches in the up position, and I position it in such a way that the end of the protective jacket is about between 13 and 15 millimeters away from the cutting edge, and that's marked off on the graticule here. Once I've done that, very gently laying this into the V groove, which locates the fiber, I lower the left-hand clamp lightly, then the right-hand clamp, and I clamp the left-hand side down firmly, and then the right-hand side. The fiber is now located firmly in between the area where it's going to be cut by the ultrasonic diamond cutter. I put a little bit of tension on it by simply releasing the right-hand lever, and now it's ready to cut. I activate the cutter by simply putting the switch down, and a little green LED will come on here. You'll hear a sudden little tink when the scoring of the fiber has taken place, and the pressure that we put on the fiber causes the fiber to separate in a clean, right angle or perpendicularly cleaved edge. So we'll do that now. I'm turning on the cleaver. And that's done. As soon as the cleaving is done, I lift up the switch and disengage the ultrasonic cutter. There is now a shard of cutoff from the end of the fiber. I need to discard that in a safe manner, like the last one, to make sure that that doesn't get into someone's skin inadvertently. This fiber is now ready to put into the fusion splicer. The same process will take place on the blue fiber. This fiber is now cleaved and clean. It must be very carefully put directly into the fusion splicer and not cleaned again. Any touching or bumping of the end of that fiber into the table or anything else will cause that fiber damage, will be noticed by the fusion splicer and may be rejected when it goes to actually do the quality control before the splice. In the T36, the lid also comes off to reveal our removable screen. And in fact, this screen can actually be lifted off and placed in various locations. We won't need to do that in this particular lab. The cover lid then flips up, revealing again another area where the two fiber optic cables come in for fusion splicing. This is a close-up of the T36 splice area. Once the lid has been removed, we can see that there's also a clamping mechanism on either side to hold both of the fibers to be fused together. The clamping mechanism is a little different than that on the T35 in that it has two inner clamps which actually rest on the bare fiber very close to where the splice takes place. It also has a larger, coarser clamp which sits on top of the protective sleeve part of the fiber. When I remove these, it reveals, like the T35, two needles in the center across which a high voltage arc is developed, which is responsible for fusing the two fibers together. When the fiber is in place on both sides, the protective part of the fiber is clamped down, and then very lightly the clamp goes onto the bare fiber, and then it will be ready for splicing. The power is turned on for the T36 by turning to the AC side, since we're not using a battery. As we can see, the screen goes into a initialization mode. I place the fiber by going down at an angle, trying to get it within 1 millimeter or so of the center gap between the two high voltage arcing needles. This one I find a little bit easier than the T35, and as far as there's a green laser light in there, which allows me to more easily see the fiber in the center. I push the outer clamp down to locate the fiber in the V groove, and then the other clamp which holds the bare fiber on the inner part. I'll now place the other fiber on the other side of the T36 clamp mechanism. I just prepared this on the cleaver as well, and trying to place it on a diagonal coming into the center. The green LED laser light helps me to see fairly well. I locate the fiber between the location pins further back, and I close down the outer clamp. Once this is done, I close the lid, making sure that the fibers make it out of the two guide holes at the side of the lid. Now we're ready to do the actual fusion splice itself. It's first to push the set button to instigate the whole procedure of the quality control, the alignment of the ends, the examination of the cleave angle, and so forth. So let's take a look at that now. We're now looking at the output display of the T36 fusion splicer. The two fibers have already been seated and clamped in place, ready for a fuse. And I'm now going to push the set button. Two fibers are being brought into the middle. Their ends brought close together and examined. It says continue, press set, and the arc takes place. And we can see that the estimated loss of this particular fusion splice is 0.02 dB, well below the 0.05 dB we expect for this lab. Probably could have done a little better job if I'd taken more care to clean the fibers beforehand. I then release the clamping mechanism on both sides, holding onto the fiber while I do that, so that the virgin, unprotected fusion splice is not stressed in any way. As before, I then slip on the sleeve over the freshly fused fibers and try to locate that as close to the center of this as I can, opening up the two doors for the fusion sleeve heater. I place that in the center of the heater bay. One last final adjustment to make sure that the sleeve, or that the fusion splice is actually located roughly in the center. I then close the two doors, and I'm ready to perform my heat shrinking. The T36 is a heater set button, which I push, and that lights a green LED on the button as it goes through its procedure. And since I'm finished with the rest of it, while I'm carrying on with this procedure, I can close up my fusion splice area. And in fact, while that's taking place, I actually could be going on and doing another fusion splice. This machine is made for a much higher yield than the T36. It's a more modern device. So I can actually be, someone could actually be preparing two new fibers while I'm splicing one, placing a sleeve on, putting it into the heater, splicing the next one and so forth, and then cooling in the tray. And in this way, we can attain a lot more productivity and therefore make our company a lot more money in terms of the number of splices I can accomplish per day. Now the heater set is complete. The green light has gone out on the button. I release the 2 doors on the bay, and lifting this up, I place it into the tray to allow it time to cool, because recall the plastic of the heat shrink tubing may tend to bind on the black seating of the Fosk tray if we put it in while it's still too hot. It's a good idea to leave it in the tray to cool for a while before attempting to place it in the Fusion Splicer tray.